Welcome to JD's Prep. In this problem, we're told that Gretchen has $50 that she can spend at the fair. The ride tickets at the fair cost $1.25 each, and game tickets cost $2 each. She wants to go on a minimum of 10 rides and play at least 12 games. Of the four systems of inequalities that we are given, we want to know which one represents this situation when R is the number of ride tickets purchased and G is the number of game tickets purchased. So the first thing that we can do is we can look at the minimum number of rides and games that Gretchen wants to play. We're told that Gretchen wants to go on a minimum of 10 rides and play at least 12 games. If R is the number of ride tickets purchased, then Gretchen is going to need to purchase at least 10 ride tickets. And at least means we are going to have greater than or equal to. She could go on 10 rides, or she could go on more than 10 rides. So we would have R being greater than or equal to 10. For the at least 12 games, it's the same idea. In order to play at least 12 games, she can play 12 games or more, which means she would need to purchase 12 or more game tickets, which would again be greater than or equal to. Since she has a total of $50 that she can spend at the fair, then if we look at the costs of each of the tickets and add them together, that can be no more than 50. So the total cost here can be no more than, which is less than or equal to, 50. Since the ride tickets cost $1.25 each, then the total cost for the ride tickets would be $1.25 times R. And since the game tickets cost $2 each, then the total cost for the game tickets would be 2G. So the 1.25R plus 2G gives us the total cost of the tickets that Gretchen is purchasing at the fair. And as we said, that total cost must be less than or equal to 50. So our system of inequalities must have these three inequalities in order to be correct. Number one, looking at the first inequality, 1.25R plus 2G is less than 50, doesn't include the possibility that Gretchen spends exactly $50. So that one's out. Number two, our first inequality, 1.25R plus 2G less than or equal to 50, is exactly what we found for the cost inequality. The second inequality, R greater than or equal to 10, that's going to allow Gretchen to go on a minimum of 10 rides. And G greater than or equal to 12 is allowing Gretchen to play at least 12 games. So this is the system that we want. Looking at the remaining two, number three has the correct cost inequality, but this last inequality down here, the G greater than 12, is implying that Gretchen is playing more than 12 games. At least also allows the possibility that she could play exactly 12 games, so we don't want to use the strictly greater than here. Number four has the same problem to start that number one did, in that we have the less than instead of less than or equal. But the second inequality is also a problem, because it says that R must be less than or equal to 10. This would be the correct inequality if Gretchen wanted to go on a maximum of 10 rides. If Gretchen wanted to go on a maximum of 10 rides, then we would have the R less than or equal to 10. But she wanted to go on a minimum of 10 rides, meaning 10 rides or more. So this one is also gone. The only one that has all three inequalities that we need is number two, so that correctly models the situation that Gretchen is facing.